can't believe this. Guys, I found a book here and jokes about matter. Hear this one. Rest in peace, boiling water. You will be missed. M-I-S-T. That's funny.
No, it's not.
Alright, hear this. I made a chemistry joke, but there was no reaction. You can believe that?
That's even worse.
Then why are you smiling?
Because
you think it's funny, admit it.
code in.
Greetings, Super Science Squad. The owners of a beverage company needs your scientific expertise. They're opening a hangout drink spot to sell drink combos to their customers. They want one of their drink combos to be a special layered beverage. However, they're having challenges developing this offer. Your mission is to create a unique combination of liquid floating upon liquid. This will be done using any of their bottled beverages. You must use at least 3 different beverages to make a colorful combination. They also want their customers to have a tasty experience. Samples of the company's drink beverages are en route to your location. I'll contact you in 24 hours for an update. Proton out.
Okay, so before the beverages come, we need to come up with a plan.
We don't even know how many samples we're getting.
Are you going to have to taste them all?
I hope not. I'm not a fan of drinks.
I volunteer to be the taster.
Sure, Star, but we're going to need to determine how we're going to select the beverages before we even get to that.
We need to identify what makes one liquid float upon another.
Help us figure this out. How would make one liquid float upon another liquid? Something to do with the particles, maybe?
I can understand a solid holding up a liquid because the solid particles are packed tightly together, so the liquid has no space to go through them. But how does a liquid hold up another liquid when there are enough space that the liquids can combine? Wouldn't they mix and mingle?
I suggest we go to the kitchen to test some liquids and see what we come up with.
Then let's go. Alright, what do we have in here as liquids?
Water,
I see some milk.
And some kind of drink. Honey, that's my name.
You're right, I meant liquid.
I knew that. These should be enough.
Let's get some cups so we can examine them closer.
Honey.
Alright, so we have milk, honey, drink, and what else?
water, I'll get it.
Pour. Use the lines on the cup to keep the volume constant to the water.
Okay.
See how the honey is going to work and the milk and drink?
Some flow easily and others really slowly. The slower ones seem to be the thickest and heaviest.
So heavier means more mass. So we need to consider mass when deciding how to layer them.
So not all liquids are created equally.
So heavy liquids at the bottom, light on top, and something in between for the middle.
But I'm curious, guys, these have just about the same volume but different mass? I don't get it.
Me neither.
You know what this reminds me of?
What?
Traffic. We say that traffic is heavy or light, right? So suppose the traffic on one road is filled with cars, bumper to bumper, and another road has few cars. These two roads are the same length, but the number of cars on them are different. The roads could represent the volume, and the cars could represent the particles. A liquid can have more or less particles in the same amount of space, like more or less cars on these roads. It's like particle traffic or something. Some liquids have more particles in the same amount of space than other liquids. And that would make the mass different because more particles mean more mass.
Okay, so using your analogy of traffic, when traffic is light, the cars move about more freely, right? But when traffic is heavy, the cars can't move about as freely because there are more of them on the roads. So that's why more particles like cars in traffic make liquid flow slower?
I think so.
This sounds silly. How about we just test them to see which liquid can hold up water?
Have you ever seen liquid floating on liquid? How do you think we should make these float on each other?
We will separate them into heavy, in between, and light. Then do the layering.
Honey is the heaviest and thickest for sure. Then
Milk, in between.
water and the drink are the lightest.
So let's use honey, milk, and drink.
The milk is not thick as the honey. I think that we should break the flour a little.
Okay, get me a spoon.
Oh no, it's not working.
Well, obviously the milk mixed with the drink, it seems as if they were nearly of the same mass. So when we're laying the beverages, we should use a balance to measure the mass for accuracy. Samples are here.
We'll clean up while you go get them.
I got the balance.
OMG guys, I got them. And they also sent us the glasses so we know how much to use and what they look like.
I'm so excited. I really like this mission.
And it's like they're reading our minds because all the samples measure the same volume.
Good. So basically, we'll make our selections based on what we just did, keeping in mind color and taste.
Yes, but before we begin, let's make sure that we're all on the same page. What do we know about liquids? 1, they all flow. 2,
Some of the same volume but different mass.
3,
Some of substances which determine how they flow.
anything else?
No.
Okay, let's keep these things in mind as we go on.
Just by looking at this, I can see that the syrup has more mass than the soda water, so the syrup is definitely going to go to the bottom of the layer. Well, the soda water is light and airy because it's carbonated, so it could go to the top of the layer.
We'll confirm that with our measurements, thank you.
So to get the correct measurement of the liquid, we need to subtract the mass of the bottle.
True, but I think we can do that later as it won't affect what we're doing now.
Okay.
So Kelvin, you were right about the syrup. It definitely has more mass than the soda water, which has the least mass.
So we just need one more to go in between.
Alright, so the syrup is sweet. So are we going to use the same amount of all the liquids?
We could vary the amount of liquid.
But if we use more of a light liquid, would it not make it heavy and mess things up?
Guys, let's try it and see. We need another liquid.
Orange juice?
Okay, so Core, fill most of the cup with the orange juice first and then add the syrup.
You sure?
No, but we'll find out. Add the syrup and remember to use a spoon.
So the syrup is still heavier even though there's more orange juice?
That means when volume changes, mass also changes.
This is so cool! This is what I call a rainbow orange juice. Colorful? Check! Now for the...
One part? Wow.
I was going to say taste test. Will someone get star or straw, please?
Wait, let me take a pic first. Okay, go ahead. Alright, I let Dr. Putin know where we're on this.
Tasty.
Check.
Coding.
Greetings, Triple S.
Greetings, Director.
Where are we now?
Alil, go ahead.
Okay, we already knew that all liquids flowed, but today we observed that some liquids flowed more freely than others. We also found out that mass can affect how liquids flowed. What we don't know is how one liquid that has more mass will still be heavier than another liquid with less mass.
So the volume
At a higher
and mass
volume,
of the substance
in our test,
both
we
increase
used way
in the
more
same
orange
ratio,
juice than syrup,
causing the
and
density
syrup
to
still
remain the
sank to
same.
the bottom.
Alright, that's a mouthful. What you're talking about is density. Density is how many particles there are in a certain amount of space. Density varies between a solid, liquid, and gas. But the density in solids, liquids, and gases may also vary. So, you will find that some liquids are heavier or have more mass than other liquids. They have more particles in that space. They are more dense. We can calculate the density by dividing the mass by the volume.
Mass is determined by the amount of matter, that is, particles, in a substance. So the volume and mass of the substance both increase in the same ratio, causing the density to remain
The same. So, if a liquid is denser than another liquid, even if the volume changes, the density remains the same.
Still not getting it.
Okay, say I had 2 glasses and I filled each of them halfway with water, approximately 120 milliliters each. That's my volume. I measured the mass of the water for each glass and it was 120 grams each. Now, supposing I poured one of the glasses of water into the other, what would be the volume of the water I now have?
So that would be 120 plus 120 milliliters, so 240 milliliters.
Great. So the volume increased from 120 to 240 milliliters. What would be the mass?
120 grams plus 120 grams, that would be 240 grams.
So you see, both the volume and the mass has increased. Since both of these change at the same rate by doubling, the density would also be the same. Let's check. When we had the 2 glasses half filled with water, the density for the water in each glass was 120 divided by 120, and that equals...
120 divided by 120 equals 1.
Good. After we poured one into the other, we had 240 divided by 240, and that equals...
240 divided by 240 equals 1.
Exactly. So it wouldn't matter if you use a large amount of one liquid compared to a smaller amount. The density will remain the same.
I get it now.
Well, good job Super Science Squad. And if Star is pleased with the taste, I'm sure the customers will be as well. Prepare your report so I can send it to the client. Proton out.
Okay, Star, I'm jealous. I want to taste it too. Me too.
You three.
You have to try, yes.